Hi guys, so today we're going to be doing inequalities involving two triangles. So we're going to start first with side angle side inequality, right? So this is why it was important that before I was making you write congruence postulate or congruence theorem and stuff like that. The reason why is because we also have similarity congruence theorems, and in this case we have a side angle side inequality or the hinge theorem. Okay. So this is what it says. Two sides of a triangle, if we know they are congruent to two sides of another triangle, so note BA is congruent to QP and then AC is congruent to PR, right? So two sides of the triangle are congruent. If the included angle, the angle in between these congruent sides, in the first triangle has a greater measure than this, so if angle 1 is greater than angle 2, what we know is that the third side, the side that isn't congruent, it's going to be longer than the third side of the other one. Okay? So we're going to be using that as we're doing example 1. Okay? So here we're going to write a 2-column proof. Several things we know. YZ here is congruent to XZ. Okay. Z is the midpoint of segment AC. And then we know that the measure of angle CZY, so that's this one here, is greater than the measure of angle AZX, this one here. And we also know that BY is congruent to BX. We want to show that BC is greater than AB. Okay. So let's start with our proof. So statement and reason. So I'm just going to write down everything. Sometimes some people like to write the given statement after, like, right before they're going to use it, but sometimes it's just easier to write it all together. Okay, so YZ is congruent to XZ. Z is the midpoint of segment AC. The measure of angle CZY is greater than the measure of angle AZX, and BY is congruent to BX. Okay, so this was all given. So based on this, then I know that YZ equals XZ, the length of them, and BY's length is the same as BX's length. The reason I can say this is definition of congruent segments. Okay. Then 3, talking about since Z is the midpoint of AC, that means that AZ, CZ equals AC. This is the midpoint theorem. Okay. And then, so now, here I have congruency, and then here, through step 3, I have congruency. So now I can use my side angle side inequality, right? Since angle CZY is greater than angle AZX, that means CY is greater than XA. So CY is greater than XA, and the reason for that is my side angle side inequality. Angle side inequality theorem. Okay. So then, if we're talking about our properties, then I'm going to do my segment addition postulate. And so then AX plus BX is AB, and CY plus BY here is CB. This is the segment addition postulate. And then here, then we also know that if these are equal, right, if BY and BX are congruent, and we already know that CY is greater than AX, what that means is that CY plus BY is greater than AX plus BX. Right, so all I did this. Right, so actually, maybe it would be better to say BY. Okay, this is my addition property. Okay, and then I can just replace it with BX. Okay, so then this is the substitution property. Right, so step 6, I added BY to both sides. Okay. Step 7, since BY equals BX, I replaced BY with BX. And then now, CY plus BY is CB. AX plus BX is AB. So I can substitute it in. And then this is also the substitution property. And then another way to say CB is BC. Okay. But it's the same thing. There you go. I just didn't like it. They weren't quite consistent, I feel like. Like, if you're going to call this AB, you should call it CB. But anyways. Okay. So why don't you try example 1 on your own, and then come check your answer. Okay, so here you should have something along this line. RQ is congruent to ST that was given to us. And then the book didn't do this step, but sometimes they do it, sometimes they don't. So I just put an extra step of RQ equals ST definition of congruent segments. Okay. Then I did QS equals QS. I did the reflexive property on that. What the book did is they instead put this on top and wrote that they were congruent. That works as well. Okay. Then I said that measure of angle 1 is greater than measure of angle 2. That's because of the exterior angle inequality theorem. The book then inserted, prior to this step, stating that angle 1 is an exterior angle. So, is an exterior angle for the triangle QTS. Right. So again, I didn't do that, but yeah. Okay. And because then their reasoning was definition of exterior angle. So in that case, I don't feel like that was as big of a deal. But yeah, so then exterior inequality theorem, right? Because the exterior angle is going to be greater. And then as a result, RS is greater than TQ because of the side angle side inequality theorem. So here I just added some stuff. The book changed some things. Instead of talking about the measurements, they just talked about congruency right away. But either way is acceptable. Okay. Okay. So the next one here is example 2. Here we're going to prove triangle relationships. And what the book did is they decided to do a flow proof. So we're going to do a flow proof as well. Okay. So let's get started. Okay, so here we know that AB is congruent to CD, so these are congruent. Okay. And then we also know that AB and CD are parallel. Okay. So I'm going to start with AB is congruent to CD. So AB congruent to CD, and the reason I can state that is because that was given to me. Okay. Then we also know that AB is parallel to CD. Okay. That was also given to me. Okay. And then because they're parallel, what we know is that this angle and this angle are going to be congruent, and then this angle and this angle is going to be congruent. And so from there, now I'm going to state that angle BAC is congruent to angle DCA, okay? And then angle ABD is congruent to angle CDB. And then the reason I can say that is this comes from this, and then this is the alternate interior angles postulate. Only corresponding is postulate. Okay. Then, because now I have angle side angle from this and from this now, we're going to say that the triangles are congruent. So triangle ABO is congruent to triangle ABO, so then I have to go the same way. CDO. Okay. And this is because of angle side angle congruence postulate. Okay. Okay. Then from there, what we're gonna do is, since we want to prove that angle AOB, this one here, is bigger than angle BOC, okay, we're gonna talk about DO. So DO is, there's no arrow, there's nothing that's going to that. So DO is congruent to DO. Okay. This is the reflexive property. Okay. We also know that CD is, so then we have DO is greater than DO. Okay, so now we're proving that these here are congruent. Okay, so, because we want to do this angle and this angle. So, this angle and this angle. Okay, and then we're going to say that CD is greater than AD. That was given to us. And then from here, we're also going to say that AO and CO are congruent. This comes from proving that the triangles earlier, the top one and the bottom one, are congruent. So then we're using CPCTC. Okay. And then here, what we're going to use now is we're going to use these three things, and we're going to use our side inequality here. Okay. So what this tells us is that if two sides of a triangle are congruent to two sides of another triangle, and then the third side in one triangle is longer than the third side in the other, then the angle between the pair of congruent sides is going to be greater than the corresponding angle in the second triangle. Okay. So basically what happened, because basically what we're doing is we're going to use side to talk about these two triangles here. So now, what we're going to say then is that the measure of angle COD is greater than the measure of angle AOD. Right. So that comes from this, right? So if AO here is congruent to CO, and DO is congruent to DO, and we know that this is bigger than this, what we now know is that this angle is going to be greater than this one because this side is bigger than this side. Okay? And so that's what the side inequality theorem tells us. Okay? Then what we're going to do is we can talk about the angles being congruent. So here, this angle and this angle are vertical angles, this angle, this, so then they're going to be congruent to each other. So angle COD is congruent to angle AOB. Likewise, angle AOD is congruent to angle COB. I can't fit it all, so vertical angles are congruent, or vertical angle congruence theorem. Okay. This, running out of space, leads us to say that the measure of these angles are equal. Okay. This is definition of congruent angles. Okay. And then from this to this, okay, I can replace COD with AOB. And I can replace AOD with COB. And this is the substitution property. So that was a lot. Okay. There we go. So there was a lot of parts here. We had to prove that the triangles were congruent, so that way we could talk about specific sides. Okay, then we needed to talk about these two triangles. Okay, with the given to use our side-side-side inequality, we had to prove that two of the two sides are congruent. Two of the three sides are congruent, and then the third one has an inequality. Okay, so that way we can talk about the inequality of the angles, and then using vertical angles, we can replace it to say that these other two sets of angles, one is greater than the other. Okay, so you're going to work on CYP2 now, and then once you're done, come check your answer. Okay, your proof should look something like this. So I started with the given segment NK is a median of triangle JMN, and I also know that JN here is greater than NN. Okay, so point K would be the midpoint then of JM. So again, definition of median, because the median goes from the vertex to the midpoint of the other side, the opposite side. Okay. So if K then is the midpoint, that means JK is congruent to MK through the midpoint theorem. KN is congruent to KN. Okay. So now what I know is this is congruent to this, and this is congruent to itself. And so now, with this being greater than this, I can state that measure of angle 1 is greater than measure of angle 2 through the side-side-side inequality theorem, right? Which tells me if two of the sides is congruent to two of the other sides for one of my triangles, if one of them is longer than the other, then the angle opposite the longer one is going to be greater, have a greater measure than the shorter one. And there we go. Okay. So now we're going to do example 3. We're going to write an inequality using the information in the figure. Okay. So here, what I notice is I have two triangles. Okay. I note that PS here is congruent to RS. Okay. QS is congruent to itself. And then here, QR is greater than PQ. And so what it means then is that the angles opposite it, the angle opposite the QR, which here is 46, is going to be greater than this one here opposite the 14, which is 5x minus 14. Okay, or another way of saying it is the 46 here, which is my QSR, is going to be greater than my measure of angle QSP. Okay. Here we want to find the range of values containing x, so of course an angle has to be greater than 0. Okay. And then we know that 5x minus 14 is going to be smaller than this 46. Right? Another way of saying 46 is greater than this is to say that this is smaller than 46. Okay? I'm going to add 14 on both sides. And then divide by 50. This is 14 over 5. 60 divided by 5 is 12. So this is 2 4/5. Okay. Or you can also state that as 2.8. Okay. Either way is acceptable. There we go. Okay. So why don't you try 3A and 3B on your own, and then once you're done, come check your answer. Okay, this is what you should have gotten. So JH and GH are congruent, and EH is congruent to itself. Okay, so then, if JE, EG, other things being congruent here, that means this side, which is bigger, is across the bigger angle, which is why angle JHE is greater than angle GHE. Okay. And then with that in mind, I can now find the value of x, right? Which means that this one is greater than 65, or another way of saying it is 65 is smaller than 6x plus 15, okay? In this, since it's a triangle, it has to add up to 180, so it has to at least be less than 180. So subtract 15 on both sides, I get 50 and 165. Divide by 6, simplify this, it will be 8 1/3. And then simplify this, this will be 27 1/2. So x has to be between these numbers. Okay. So now we're moving on to our last example, which is example 4. So the range of motion describes how much a limb can be moved from a straight position. To determine the range of motion of a person's arm, we determine the distance from the wrist to the shoulder when the elbow is bent as far as possible. So Jessica can bend her left arm so her left wrist is 5 inches from her shoulder, but her right arm, when her right arm bends that way, her right wrist is 3 inches from her shoulder. Okay, so which arm here has the greatest range of motion, and we will explain. Okay, and so what we know then is that the right arm has a greater range of motion. The right arm has a greater range of motion. Okay, because the distance between the wrist and shoulder, between palms dying, the wrist and shoulder, is smaller on the right arm. And what that means is that the angle then is also smaller, right? And so then that means she has more range of motion. Okay, so here you're going to do CYP4 and then come check the answer. So you should have gotten that Jessica's left arm now has a greater range of motion. The reason why is because she could move this arm farther than the right arm, which is why her left wrist to her shoulder is only 2 inches away compared to her right wrist, which is 2.5 inches away. That's it for today. Thank you for sticking it out. Have a great rest of the day. Bye, guys.